Pro. This was a pretty big deal. So we came up with an exclusive technology. We call this Instigate Pro. So this is an AMX exclusive technology. Basically what it is it's a specific type of algorithm, if you will. It's a dialogue that we have. It's a way that we basically make sure that all the sources that are connected to us, we're always authenticated with the source, and then our switch ourselves acts as the HTTP handshake, if you will. We maintain a relationship with the monitor to make sure that any endpoint, anything that's connected to our output is HTTP compliant. If what's connected to our output is not HTTP compliant, we don't allow a signal to go to it. And on the source side, we maintain presence and a handshake with the source device, so there's never a renegotiation of that key, exchange. So if I route a Blu-ray to monitor 1, and then I go to route it to monitor 2 and monitor 3, monitor 4, that Blu-ray never sees that there's 16, 32, 64 things attached to it. It just has one key handshake with me, and it just keeps putting out its output, so it's fine.
So there's no limitation on the amount of screens that it can go to?
That's correct. Okay. That's correct. The only limitation is the display's own HTTP compliance. Because again, in this particular example, let's say I take a Blu-ray player and I route it to, let's go to a couple of monitors there. We see that, maybe that's not the one I've got. I'll do this one. So you notice that the switching speed was instant. Yeah. And then we routed it here. You saw it show up on 3, but we realized that this old Apple monitor is not HTTP compliant. So we actually give it a red screen. So we kind of go a step above. We don't just not deliver the image. We actually give them validation that we can do it. We're not going to, because you have a non-compliant display at the end there. So one step further we take is our firmware also allows for us to maintain a revocation list. Have you guys heard of a revocation table? No. So revocation is part of the HTTP schema that basically says somewhere within the firmware, a device has to be able to get an update from the internet, and basically HTTP keeps track of any monitors, any sources, whatever, that fall out of compliancy. Let's say you've got a display manufacturer out there that, when they did first testing, they deemed themselves appropriate. They were following the rules. It looked like content would be protected within that display. Well, after shipping the product for maybe a year, maybe someone finds some exploitable way to pull that content out of that display. Well, if that display manufacturer doesn't change or close that loophole, then basically HTTP could go and say, actually, you, Mr. So-and-so manufacturer, that specific model is exploitable. There's a way to get content out of there. We're going to put you on this revocation list. And it's kind of like a blacklist, but it's really just saying this is no longer compliant. So what could happen is maybe this monitor is compliant today. 6 months from now, if all of a sudden this particular Dell monitor became incompliant or uncompliant, through a firmware update, through some kind of interaction here, this revocation list would be updated. We would know that he's not compliant, and we would no longer route HTTP compliant sources to this guy, right? So we do fully handle the HTTP. We maintain compliancy with basically what HTTP set out to accomplish, protecting content. So Instigate Pro, while Instigate Pro is an exclusive technology, I'd say the major manufacturers at this point have some flavor of their own algorithm that basically keeps HTTP switching fairly fast, right? I mean, Extron and Crestron both, they've got pretty quick switching speeds. You guys may have seen that video. I don't know if you saw it, but it's the only switch that counts. Don't know if you guys have seen that. So basically, well, we'll talk about it offline, but it's a great video that just kind of shows we're all doing some pretty good fast switching speeds. But it's important to know that there are a lot of manufacturers in the marketplace that don't have this kind of technology built in. So there's products where it's just a base switcher. If you see an HDMI switcher, you connect stuff in, it may or may not switch because it's not really doing anything. It's not really doing any handshakes or negotiations. And really, you can really tell which products out there don't, because there's a huge price delta. You get into some really low-end switching all of a sudden. If there's a huge price delta, you know that there's probably a lack of this type of technology in there. So On the destination side, this really gets more into the adaptability that we talked about with designing switching systems, and it gets into kind of that ubiquitous mobile trend that we're tracking on, and you know, all those mobile devices that are out there. There's, you know, you figure at 9 billion mobile devices. That's 2 devices per every adult on the planet, right? There's a lot of mobile stuff. So you find more and more people walking in with their iPads, walking in with some kind of tablet, and that's where their content is. They're going to plug it in, and we have to just be able to accommodate it. Now, think about how many tablets there are in the marketplace right now, how many different resolutions there are coming out of those things. It's changing every day, right? There's always something new coming out resolution-wise. So the idea here is, let's say that we have, this kind of goes to what I was originally talking about. If I just have one source, I'm routing it to one monitor, it's a no-brainer that this source I've got is going to output the best thing that will match up to this. The highest resolution this supports is 1920 by 1200. If my device supports that, I'm that resolution. No problem, right? Now, the minute that I go to a second monitor, now I have to look at that and go, well, I've got that one source. The second monitor doesn't have 1900 by 1200. Well, the next best resolution it has is 1920 by 1080. Great. So now the source, I got to tell it to bump down a little bit, right? I got to say, don't give me 1920 by 1200, only give me 1920 by 1080. Not too big a deal. We're still talking about 2 million pixels worth of information. That's all right. The real challenge in our marketplace and in our industry gets to when we add this third device, which is typically the video conference codec. This is our, you know, our Polycoms, our Ciscos, our LifeSize, you know, all of these devices. All of them out there, at this point, still their max input resolution is 720p. Now that sounds like a good number because we know our own personal adoption of information. 720p is a lot of detail, but when you compare what is 720p equal from a pixel count standpoint versus what did we start off with, that's a huge reduction in the amount of information. So if I'm doing any kind of government command and control, if I'm a high-end residential system where I'm paying top dollar for all the best, for all this content, for all this information, I want all that information. 60% reduction in the information could be the difference between, in a command and control or some kind of monitoring scenario, knowing whether or not there's just, you know, the person I'm looking for, or yeah, a person could be there, right? That's a huge difference.